I told them I'm just about ready to hit send for their very last assignment sheet.
Nice.
Yeah.
Oh, that sounds wonderful.
I do have questions, but I gotta just hurry up and feed a cat, so I'll be right back.
This is not where I want to go. While that's happening, I also want to start with the project then, the projects, the last two projects. Because we've covered all the material you need to do project 10 and 11.
Eric, just to let you know, the 11.2 worksheet number 2, we did a majority of it and talked about most of it. So unless you might want to just answer any questions from it.
Gotcha.
So that might help a little bit.
That sounds great. Laura came early and mentioned that too, so.
Perfect.
That's good. Yeah, so that'll give us more time. And the nice thing about that one is we already did it. It's the chapter 10. It's chapter 10. Just we subtracted some numbers. Okay, so let's scroll ourselves in the stuff down to what is today? The 5th? The chapter 10 project, which says it's due today. There's like 2 little things I want to make sure you get. So first, I'm going to open the Google Docs and download the Word document. So here's this. Remember, you go File, Download, Microsoft Word document. And then the other, enable editing if that happens to you, which probably will, I don't know. And then the other thing you should do is go to this equations file available here. And this is key. When you open it, it's another Word document where you can see it, but you're not going to be able to copy and paste from the Google Doc. It won't paste correctly. So you need to also download this document if you're going to do this. File, I forget how we did chapter 9, if you all chose to print it and handwrite it or not. I think you hand wrote it.
Yeah, because I thought I tried to download it and then tried to copy and paste and it still wouldn't work. I don't remember if I really did that though. I do know I couldn't copy and paste. I just couldn't remember.
Gotcha. Yeah, you can't do it without downloading, that's for sure. You do not need to. I would argue that printing this and doing it by hand is much easier.
That's what I did.
So do that by all means. We have had a history of fun with these things, right? I'm not going to spend a lot of time on this because I just want to mention, make sure you're clear on what you're doing. I think you all can do this. You should have your data here from that first counting that we did ages ago. So you're just going to pick your lowest count in your sample, lowest color count, tell me your color, put in your X, your N, and then do your X over N. Number 2 here is a claim. So this is really step 1 of hypothesis testing.
Can I just stop for a second and ask a question?
Please.
This came up on chapter 10 review, and now it's coming up here. When it says 1/6, I put in 0.66. And when it says like 1/3, I put in 0.33. But I'm getting answers that are a little bit off. So if there is a fraction, should I leave it a fraction?
Well, in the directions here, it says use a fraction. What I will say is 1/6 is incorrect rounding. I mean, sorry, 0.166 because it's 666. So
you have to do more 6s.
It should be a 7.
Oh.
So the very
Oh.
last number, however many numbers you put, the very last one should be a 7. It's somewhere in there. So
Okay.
if you want to be more accurate, you can just make
No,
sure
I'd
you
rather-
make it 7.
I'll just use a fraction.
Yep, and you can just use a fraction. Either way, it'll be fine. Okay, so there's that. Then you have your verify, which I'm sure you all are sick of doing, but enjoy.
So for number 2, we just do step 1?
That's all that is.
Okay.
It says write the appropriate hypotheses. In other words, I'm looking for this. Based on what you read there in number 2. The one I wanted to make sure you saw was this one. So we're going to randomly select a level of significance. You all remember what level of significance is, right? This is step 2 or alpha. So you can click it here. I'm control clicking. I'm trying to. It's not working. There it goes. And it's going to open the StatCrunch this thing. Or you can go back here and the random levels of significance right there in the chapter 10 project. You can click it there. And what this does is it pulls up a column of levels of significance. You're going to do this twice in the chapter 10 project, and you're going to do it twice in the chapter 11 project. So what you're asked to do is randomly select one of these numbers. And the way you do that is you do a sample. So you go to data and sample. You pick the column you're working with, and we're just going to do one sample. And that's all you need to do. Don't worry about anything else on here. And click compute, and then it says new column. And there it is. I got 0.06 as my random level of significance. So I'll do it one more time. I'll generate another one. You go to data, sample. You select levels of significance, that column of data. We're going to randomly select one of them. Actually, since you have to do 2, you could select 2 and just have them both done at once. Click compute, and there's my second one, 0.02. So that's what you need to do for question 4 and question 10. Just get 2 random levels. And then I think you did that in chapter 9. And then you're going to do the same thing for the chapter 11. And then it's 2 hypothesis tests. Number 11 is a hypothesis test with the alternative, the hypotheses from number 8. And number 5 is a hypothesis test with your hypotheses you wrote in number 2. So this is a single sample, all right? How do y'all feel about that?
Good. Do we get some time to work on this right now, or are we going to work on this on our own time?
I think, well, let me talk about chapter 11 project. I think we should probably, I don't know, how difficult was 11.2 for you all?
Very. I'd like to go over that.
Of course,
So-
Eric, the most difficult thing was writing the alternative hypothesis.
Yes, that's very challenging. Yeah, so we should I want to spend more time with that. Let's look at the chapter 11 project too, just so you see what's happening there. It's 11.1 material, so it's what we've already covered. This one is due on the 11th, which is next Sunday, which is our last week. We are so there. Note it has the same stuff: equations file, random level of significance, a new one, random confidence level, blah blah blah. So let me just open it and we'll look over it real quick. Same thing, make sure you download it. Feel free to print this and do it, handwrite it. I guess I even encourage that, especially, although this one has less like formulas that you're gonna have to write. So let me pause before I start talking and make sure everyone's got the chapter 11 thing downloaded. Oh, look, the Alana Tucky's right in here looking at this right now. Okay, is it cool for me to chat about this?
Sure.
Okay, so first, this can look a little confusing. What you're gonna do is you're taking just these 4 colors and you're putting in your totals for the M&Ms and your totals for the Skittles, and you're putting the number for each of these colors, and then you're calculating a p hat for each of these colors. All right. And then this one, for whatever reason, this gets messed up. So this, why is this one so messed up? So then, man, how is this so bad? So then the number 2, what you're doing is you're just copying the proportions down, which you don't need that. What I'll do is I'll just delete these first. Delete these 2 columns. So what's important in number 2 is that you're calculating the difference between the M&M proportion and the Skittles portion for each of the 3 colors. That's what's important. I'm curious as to why it's fine here. Why?
Can you
Maybe
say that? I just get my paper.
Yes. Let me suggest that if you're going to print this, download it as a PDF, and then this table won't get screwed up. So what you're doing is you're taking the proportion of green M&Ms and subtracting from it the proportion of green Skittles. So it's like 0.1 minus 0.12, and you get like negative 0.02.
Wait, hang on. Are we on 10 or 11 right now?
We're on 11.
Why does mine not look at all like that?
Because I messed with number 2. So what I'm suggesting is if you're going to print it, go file, download, and do a PDF.
Okay.
Because this number 2 table, when you download it as a Word document, it doesn't show up correctly. Like it gets blown way up and you can't see the differences column.
So for number 2, we just want the differences column. We don't care about the Skittle and.
That's all that matters. And you already
Okay.
have the differences, the proportions up here.
Okay.
But like if you have the PDF, it makes it like you.
Yeah.
The reason they're there is it's easier to see what you're subtracting. That's the only reason.
And it's
So that's-
P, where is that again? Can you go back up to that? Oh, where you split it? Is it's P hat, mu? That
P hat.
difference where you made it that one oh God, that's totally
oh.
different. Forget it.
This
I gotta do it your way. Oh, no, the one, number 2.
Yeah.
Difference P hat mu minus P hat Z, is that what it is?
It's P hat M for M&Ms minus
Oh.
P hat S for Skittles.
Okay. I have a split screen, so it's hard to see.
Gotcha. No worries. And it's a little, like I said, easier if you download the PDF because it's
It's fine.
So then the other thing to note is you're finding the largest and second largest differences in these proportions, but you're ignoring the negative signs. Okay, so for example, if it comes out to be, say, negative 0.13 and 0.17 and 0.05 and negative 0.08, the largest one is 0.17. The second largest one is 0.13, the negative 0.13. So it's just ignore the negatives and look at which is the largest absolute values, the algebra language we would use. And those are the two color differences that you're going to use to do a confidence interval, although in this one you're verifying requirements. Remember, there should be 7 items here: C1, C2, C3, C4, and essentially 2 things for all but the second one. And then you're doing another random sampling for the alpha here. I'm sorry, this is a confidence level. So you're doing a random C level here. And then you're doing a confidence interval, and you're just smashing the stuff in StatCrunch and getting your answer is just this. That's all it is. And using that to evaluate support or contradiction from a claim. Then you're going to do an alpha here, just like we did in the Chapter 10 project. And then you're going to do a how many question. And here we do want you to write down the formula, the substitution, and the result, because when you calculate a sample size, you have to type everything in like Desmos or something in a calculator. Then you're going to do a hypothesis test. Note you have to verify the requirements in number 12. Pick another alpha for 13, and then do the test here. So this is the big test from 11.1, where you're comparing the proportions. So this is the independent proportions, 2 sample independent samples. So it's all stuff you've already done. It's not anything new, but there are a few little tricky things in there. I think the first 2 pages often get students. Any questions on this?
Can you go back to number 10? You said that one was which?
This is
That's where we're doing the
how many, calculate the minimum bag size. And it's the only one where you actually have to write down the formula.
Okay.
Unfortunately, it does say prior estimates, so it's the big nasty one.
So these things we're just gonna kind of work on them on our own time. Okay.
I will be happy to take questions. I think let's not do them today, but I'll take them on Wednesday and then also Monday, because this is really good review for the final exam. These are types of questions you're going to face on the final exam. So yes, I'm happy to look at them. You can also come to office or tutoring hours as well if you get super stuck, or send me an email or whatever. Okay. Cool. So let's look then at are there any questions on the 11.2 worksheet number 2 that you all mostly finished together on Thursday? This one. Anything in here that we need to talk about before we do the next one?
I guess I don't even have that one. I have 11.2 worksheet number 3. Which one is this? Did you just pull up?
Page 720.
No, I don't even have it printed out. Now, I missed a few lectures and I haven't figured out what I've missed yet. So I'm
So this is,
behind.
you would have missed this on Thursday from Cindy's class, I think.
Yeah. And you know what, Eric? I still kind of have questions about 11.1. So I don't
Okay.
want to, I'll just keep going and then go back and review on the recordings and I'll probably have them answered because I don't have a lot. I just
Okay.
have, so yeah.
Sounds good. No worries.
Do I need to, are you going over this worksheet? Because I'll print it
We,
out.
we
right
are
now.
gonna do 11.3. I wanted to see if there's anything from what everyone did on Thursday to go over. So for the rest of you that did do that did work on this, was there anything you wanted to look at?
Hang on a minute. I guess I don't know where that was on the assignment sheet because my assignment sheet is 11.1 worksheet 2, 10.3
Peg,
worksheet.
they did it in class on Thursday. That's
Oh.
so it's not that it was necessarily, I don't know that it was,
Oh, it was a review thing. Got it.
it was a
Or a
thing in
work
class.
thing.
Yeah.
All right. No, so
Yeah.
I have no idea. Don't count on me for this.
That's okay. That's okay. We know you won't have questions. That's good. You might have some and we'll talk about them. Oh, hi, sweets.
It's actually gonna be, so we worked on it on Thursday, but it's not due, it's not due until on this Sunday.
I just listened to your Thursday before I jumped on here where you went over chapter 10 review.
Mhm.
And so, but then I stopped. So it's probably at the tail end of what I was doing. No worries. I'm
We'll
again
get there.
playing
It's
the
okay. We're
catch-up
gonna
game,
start,
but
we're
not
gonna do
nearly as
11.
bad.
So anyone else? If there's no questions, that's okay. We'll start on the worksheet number 3. Okay. Let's do worksheet number 3 then. So, how do we tell if samples are independent? What's our little phrase, our catchphrase? Two samples measured once, right?
And then dependent is one measured twice. It's like kind of the inverse. Okay.
Perfect, good. So that's for condition 2 of like any of these verify the conditions are met. Like when it says either dependent samples or independent samples, that's the phrase I'm looking for you to say. So if you're saying it's independent, it's 2 samples, you measured it once. If you're looking for it to be dependent, it's 1 sample measured twice. So apply that to number 1. Let me give you 3 minutes. It's a really important concept that you get which it is, because if you get it wrong, you do the wrong test and then you're sunk. So let me give you 3 minutes and you work through number 1, A through D, and you're just identifying, is it independent or dependent? That's it. Set a timer for 3 minutes. Okay, y'all. A, what do you think? Dependent, independent?
Dependent.
Turn off the alarm. Good. Before and after. One group measured twice. Okay, I guess it stopped. Good. How about B?
Independent.
Good. Two groups measured once. Wayne State versus Michigan State. No, wait, why am I saying Wayne? University of Michigan versus Michigan. Oh, C is a tough one.
Tricky. I said dependent, but I don't know.
You're right. So
It's tricky.
it is tricky because it is like two different people, but when we pick one person, that determines who the other person is that we measure, because we're pairing twins. Good. How
So
about
when
D?
you,
Go ahead.
if you see the word identical anywhere trying to trick you, just know that's, you count them as one. You're dependent on one for the other if they're identical, right?
Well, the another example, a very similar type of study would be spouses. So married couples or dating couples is the exact same thing, really, because if you pick the one person in the relationship, that determines the other person that's going to get measured. So it's
Okay.
not just the identical twins. I mean, it could just be even, what's the non-identical twin one?
Fraternal.
Fraternal. It could just be fraternal twins. What
It's just the
matters?
dependency of one person on the other to
Yes.
make the pair a pair. Okay,
Yes.
okay, that makes perfect
Good.
sense. Got it.
How about D?
Independent.
It feels like a pattern here, right? Yeah, two different groups of individuals, two drug therapies. Yes. Okay. Now, let me give you, maybe Cindy told you this already. When you see a table of data that looks like this with the word difference, you know automatically this is dependent sampling. You don't even have to think. I have graded final exams where the last hypothesis test on the exam was this setup and people did an independent hypothesis test on it. And I hate that because I have to decide, do I take off all 15 points? Because it's all wrong, but they correctly do the independent hypothesis test, right? Like, what do I do with that? And it's painful. I don't know. When I first started teaching, I took off all the points. And now that I've been doing it longer, I'm like, well, you've shown that you know how to do the independent test. So just note that when we give you a table of values, there's two things. Number one, you're dealing with a mean, and number two, you're dealing with dependent sampling. Okay, so note what you're doing here. You're finding the difference and putting in the table, and then you're going to do a confidence interval, and then you're going to calculate a thing or interpret a thing. So how do you all do these differences? Do you manually type them in and then type the differences in StatCrunch, or do you type both columns in and let StatCrunch do the whole thing?
I don't know how to do this because again, I've missed some classes. I was subtracting one from another. So apparently I'm way off.
That works.
We,
Go ahead, Cindy.
we put them in StatCrunch, Eric, and click the difference column and just let StatCrunch do them.
Oh, you,
Love it. That's what I would say.
I mean, a lot
These
of
are-
times you need that difference column anyways, so you might as well.
what are you doing though? Are you subtracting the top from or the bottom from the top, or the top from, a bigger number from the bottom number? I guess
So you
you just.
subtract them always this way, always the same way. So this one, it's top minus bottom. But what Cindy's saying is just type in pre and post and then let StatCrunch do all the work.
I think I could do it in my head faster. Takes me so
I
long. to
don't
stack them.
disagree with you at all.
Yeah, I can do it.
You're gonna-
This particular set of data.
Yes, I agree with you on that. There's other ones that aren't so nice that.
Yeah, yeah. Okay,
But
good.
you're gonna
Then
have to do, you have to do StatCrunch at some point. So whether you're in,
Oh.
oh boy, I screwed up. Hang on, 30, 34, 31, 26, 31. 31. No, okay, there's where I started again. Sorry. So at some point, so either you can do the differences and then enter the differences, or let StatCrunch do all this.
Gotcha.
Okay, so I guess, should I just let y'all do it? Yeah. Let me give you 3 minutes, and if 3 minutes is not enough time, we'll have you do more. Just remember, your final answer should look like this. Set a timer for 3 minutes.
So I just got all the numbers put in, so then I go to stat t-stat paired.
You got it right there.
Okay.
T-stats paired. Oops.
Do you save, do you save differences?
If you already did the subtraction, then you are not doing that.
I
'Cause if
didn't.
you,
I'm doing it. I'm doing StatCrunch. I'm embracing the technology.
so, yes, save the differences.
Okay, thanks.
Yep.
So we need the differences before we do that.
Well, it creates the differences for you.
Okay, so pre-post, and then I don't change anything for the hypothesis test.
Well, what are you doing? Oh, what are we doing in B? What question are we answering?
The then
Construct a 99.
99% confidence.
So that's why we're not doing a hypothesis test. We're doing a confidence interval.
Confidence interval
And we gotta
99.
change it to a 99.
Okay.
And then just compute. And now those differences we were calculating in our head are all right here. So we can double check our work if we already did them. Or if we weren't doing them in our head, we didn't have to do them in our head, kind of thing.
So it's just when it's dependent, you do the the confidence, and when it's independent, you do the, you,
No, it's just because we're doing a confidence interval. If we're gonna do a dependent hypothesis test. So we will click that hypothesis test at some point. It's just this problem said do a confidence interval. Does that make sense?
mhm.
3 decimal places. How's everyone doing? We all got the same thing here?
Yes,
Good. All right, try C.
I have no idea, but I think it's because it's, the notes.
So I guess I totally skipped over the context. We've got a group of business managers. They're taking a course on tax law. They're given a pre and post test. And so we're saying, is it reasonable to believe that there's a significant difference in their knowledge of tax law based on the difference between their score before they took the course and after they took the course? And if you look at the interval here, it actually looks like they did worse. But note what number, what really important number is between -4 and 1.
0.
Yeah,
So I
So
knew that,
because-
but then I didn't know where to go.
that's okay. So because 0 is in there, that means there's no difference between the mean at the beginning and the mean at the end. So no, because 0 is contained in the interval.
Is that always the answer when 0 is contained?
Always.
Eric, I think you want to go to the next one.
Cool.
Go,
To the
Which one?
last one and say it, you said 0 is not contained.
oh, yes. Thank you. Huh? You can play with that, yeah. Huh? What? I don't know. I don't know if there is one. Yes, sorry, I put in the not one when it should have been this one. Right, those are the only two answers. It's either no, 0 is contained in the interval, or yes, because 0 is not contained in the interval. It will never be either of these. Those are never correct answers. Okay.
That's
Questions
super
on
good
that?
to know.
Yeah, and this is true for back in 11.1 as well. And it's also true for 11.3 that you're going to do tomorrow. So that's what the confidence intervals for chapter 11 are much simpler to interpret. All right, so this is now another confidence interval, but we've given you everything and we're now checking that you know all the pieces. So let me give you like 5 minutes and see if you can't pull this one together. See how far you can get. Like it ends all the way down here on H. But you go, I'm going to check in after 5 minutes and see if you haven't gotten A and B done.
Eric, I don't even know where to go in StatCrunch right now.
So this is StatCrunch. So nothing, you don't need to do anything in StatCrunch. This is all, do you understand how to read the output of StatCrunch?
Oh, okay. See, this is where I get tripped up. I try to do more with the stuff that you give me and think there's a problem in there that I have to solve when basically I just have to show you that I have knowledge. All right, I have to
Yeah.
stop overthinking things. Truly, you
So-
see how many scratch offs I have on my worksheets.
The StatCrunch outputs always have this kind of grayed out box, and they have this like heading that talks about, you know, that looks exactly like what we had here. So
As silly as it sounds, the DF was capitalized and then it's not capitalized down here. So I
Yeah.
thought they were trying to trick me.
no,
All right, then I got this. Thank you.
good, good. Okay, that was 5 minutes. Do we have A and B filled out?
I do not have A or B completely filled out.
Is there any one of these that anyone's stuck on?
A-
The standard error of D is just the standard error. Okay, that's what I put. And I rounded it to 4. Is that okay? Instead of
That's
writing the
fine.
whole thing? Okay. And then the third one is the
D bar.
mean. The
So-
mean.
Yes, so this is a special
Okay.
symbol because what happens, remember what we did back
Charlie.
here? Is we subtracted all of these sample values from each other. These were paired up. So this was business guy 1. and this was business guy 2, and we subtracted all the results and said this guy had a 2% his post-test decrease. Oh, well, the way we did this is this guy got 2% worse on his test. This guy got 5% better, or 5 points better on his test, or I don't know why it's he, these business managers. And then we took the mean of all these differences. So we call the mean D bar to help us know that this is a mean from a subtraction of 2 different values. It is just an X bar, but it's a special X bar. So we call it D bar to know that we calculated the mean from the difference of the paired values. Does that make sense? Does everyone feel okay with that?
So the D bar is the mean by subtracting the paired values.
So it's the mean of the differences.
Yeah, not subtracting differences.
These added up. So these differences were all the subtractions from each of these paired values. And then we calculate the mean of each of those numbers. Or not the mean of each, it's the mean of that collection of numbers.
Mean of the difference of the paired values.
Yeah. So we have like 2 samples here, sample 1, sample 2, and then we subtract them and we create a single sample.
Right.
A new sample that's just 1, but it's a different sample. It's a difference sample. So we call its mean D bar. Okay, good. Now, notice we have these requirements to follow. And technically, we're looking at both samples, but because we have condensed the 2 samples into one by subtracting all the values, we really only have to do 4 things. Did we randomly generate the 2 samples? Yeah, that's given, right? Are we working with matched pairs? So is it dependent sampling? Yes, 2 groups measured one group measured twice. Now in this case, how do we know this? Okay, I should try to write so you can read my handwriting. Here we got the cholesterol levels from 24 random Michigan hospital employees who ate the standard American diet and then did a vegetarian diet for 1 month. So they measured them before they took the diet, and then they had them eat the vegetarian diet for a month and measured them again. And we're calculating the mean difference between their HDL cholesterol levels before they ate this vegetarian diet and after. Don't sweets. So 1 group measured twice. How are we doing on that?
Good, that's what I got. And can we expect that these are like always gonna be dependent?
Yes.
Okay,
Anytime you're subtracting, anytime you're doing a mu D or you're doing a
Okay.
paired T confidence interval, that's going to be dependent sampling. Let's see. So then condition 3, our sample size is 24. Is it independent from the population? The reason we don't have to do 2 is there aren't 2 populations we drew from, right? We drew 1 set of individuals and then we measured them twice. So these 24 people, they got pulled from a population of all hospital employees. We have no idea if this is going to be good enough. Oh, Michigan Hospital, yeah. Michigan Hospital has thousands of employees, right? And then condition 4 is normal. Are you getting sick of these graphs? The normal probability plot is approximately linear. Again, there's only one population we've dealt with, and that's the That's why we only have to do this once. Okay. How we doing with this? This was just reading the output so far. We're going to do some more. This is some more reading of the same output. So it's all there except for a margin of error. You're gonna have to do some calculation here. Try to remember a formula. And then the critical value, you're gonna have to do some calculating in StatCrunch for that one. All right, you all good? Can you do it?
And we use the data from the page before.
Yep, you're still
Okay.
using this. So I'll
Okay.
leave this page up. So if you want to look at the screen, so you don't have to go back and forth. Let me clean it up a little bit. So let me give you 5 minutes and you see how far you can get on those. Set a timer for 5 minutes. Of course, if you get stuck, ask away. Okay. How we doing? Did anyone get the confidence interval?
%90.
So that sounds like the level. Oops, and I don't know why I wrote a 96. The confidence interval is 13.662.
And then 25.421.
Good.
And I was on a phone call, so that's really good.
Nice. So the interval is the upper and lower limits. Oh, come on. How do we feel about the level of significance? I'll write a little formula that you have in your reference sheet somewhere. Remember, alpha is level of significance. We use it more often as the we use it more often in hypothesis testing. Excuse me, but it is also a part of confidence intervals. Now the margin of error, how about that one? That's the tough one. I'll draw the picture that I've been drawing every time we talk about confidence intervals. It's the lower limit.
Upper limit plus lower limit divided by 2.
Nice. Good. Which gets us this. This is the margin of error. So we're doing 25.421 plus 13.662, all of that divided by 2. Anyone got that number?
I didn't because I had a question.
Go ahead.
There was another chapter where we did the margin of error where we didn't divide it by 2. Am I right? That's a margin of error. I think it was like the last section. So I just left it at 11.759 and didn't divide it by 2 because I wasn't sure if that's what we're doing. Am I wrong about that? I thought there was something in one chapter back where we didn't divide it by 2.
So it just depends on like in section 9.4, we told you the margin of error. Oftentimes we're just like, hey, the margin of error is this, use it to calculate the sample size.
It didn't make any difference. I did the point estimate instead of the margin of error anyway.
Well, and we know the point estimate is, yeah, this is the point estimate, 19.541 or 42. And
Wait a
yes,
minute.
so it's just keeping
Wait a
track
minute.
of what.
I gotta get my glasses. Hang on. Oh, okay.
Disagreement.
No, it's okay. It's okay.
Let's see.
Here plus Adam. And it's 19.5165. And that's what you're dividing by 2.
Okay, so I get 19.5415. So Reagan, something.
I
Or did
had
I-
rounded different than you. That's
Oh,
different.
that'll do it. So yours is totally fine. Did you have 4 decimal places?
Yeah.
Okay.
How did you find the level of significance? Is it somewhere in here and I missed it?
1 minus the sea level. Which we should be careful
Okay.
because you
That I
have to
didn't know
do it
from notes. Okay.
as decimals to do it that way, or it's 100% minus 90%. All right, did you all compute the critical values? Did you get those in StatCrunch? So we would have gone to stat calculators. This is a T calculator. We need the between. We need the degrees of freedom, which was 23. And we need our confidence level, which is 90 or 0.9. And there's our critical T values.
Can you say that again slower?
Yep. In fact, what I'm going to do instead is show you where to find this in the reference material and then say it.
Perfect.
So from the
Sure,
reference
you can-
material, it's on page 271. When you're finding these critical T values, you're going to stat calculators T. You're putting in your degrees of freedom, which for us was 23. And then you're typing in the confidence level that you're using, which for us was 0.9. And then it spits out the two values, the plus or minus numbers that you need. If it had been a critical Z value, we would have done the stuff up here for the critical Z, but that's if we're working with proportions or calculating a sample size. Okay. Any questions on this part?
I thought the DF on the cholesterol problem was 9. Oh, it is 23.
No worries. Oh, I guess we should draw the picture. One of the things with the picture here is technically the shading should be on the outside. I don't know. It doesn't really matter. It doesn't matter. So you can shade outside or between, same thing. This area between is the 0.1 split in half, so it's 0.05 in each area, and then of course the between is the 0.9 area. Okay, first question, is 0 in this interval?
Yes.
Let's see. Is 0
Oh,
greater
in the
than?
interval. No, it's not in the interval. I was looking at this T.
Oh, yeah, you're right. 0's in between those two numbers. Good. But in the confidence interval in this one, 0's not there. 0's way over here. So does it imply there's difference? Yes, it does, because 0 is not contained in the interval. Good. That's what's nice again about these two sample problems, confidence intervals. We were just looking, are we going from negative to positive to not support? Okay. Oh, good. We got time. I want to make sure we do the hypothesis test. And then it looks like we'll have some time where you can work on the project if you want. So first, let's just run through these real quick. If our sample size was decreased, but all other statistics in the sea level are the same, the confidence interval would be what? Let me show you. Let's look at the formula. Oh, I don't know if that's helpful. Yeah, it is. So here's the formula. It's the same formula back from chapter 10. If we're making this number smaller, that means the margin of error, this number here is going to get large, this number is going to get smaller, the standard error. So it's going to make your interval narrower. And then here, if the standard deviation is increased and everything else stayed the same. So notice the standard deviation is in the numerator. So if we make that larger, we're adding and subtracting a larger number. It means we're going to make the standard error larger. It's going to make our confidence interval wider. And then the last one is, what if we mess with the sea level? Well, you can look at the picture here. If I make my sea level smaller, so if like I change this to 0.8, check what happens to my critical values. They got smaller. I went from 1.7 to 1.3. And if you look in the formula, the critical value is right here. So if we make this number smaller, we're going to make this margin of error smaller. So it will be narrower. Go back to your chapter 9 stuff. In 9.4, we wrote a bunch of like, as the sample size increases, this increases or this decreases. That's another place for your reference sheet to use to help answer these questions. If like looking through these formulas is confusing. Okay. So this is a nice big hypothesis test. I'm going to suggest that A be done as a part of doing D, and C be done as a part of doing D. Well, I guess we're asking to find this, really? That's annoying.
Eric, I changed that to the standard error
Okay, let's do that.
because they'll give you that in StatCrunch.
So
I
let's
know,
do
that's
this.
exactly what I said. Okay, yeah, let's just change it.
I mean, you know how to do it. Like Laura was hanging out with me this morning a little bit. We were looking at some problems. You're going to have to know how to find those things from chapter
Chapter 3, yeah.
for the final exam, like those chapter 3 material. But yeah.
For right
So-
now, yeah.
Yes. For now, let's just do the StatCrunch part. Let me show you, remind you the reference material page you're going to look at. You're doing this thing right here. So how about I give you 3 minutes?
What page is
And-
that, Eric?
This is page 278.
Thank you.
Let me have you do this. I want you to do none of the entering into StatCrunch or any of that mess. Let's get step 1 done. Okay. So let me give you 3 minutes to read the problem and figure out what hypothesis are we doing? Left tail, two tail, or right tail? Set a timer for 3 minutes. Okay, let's talk about this. Cindy, did you had them write it like this, the mu d? Okay, so we're gonna do mu d, mu subscript d. So the mean of the differences and the mean of the, oh, come on, and the mean of the differences. So this stuff is all done. All we have to do is figure out the inequality. That's it. Oh, look at you. Which is not super simple, right? Because we have to think carefully about which way are we doing the subtraction, and then what claim is it? So what did you all think? Right tail. Now I got to remember right tail means greater than. Ooh, I like that. So the claim, the thought here is that it should be this. So let's confirm that you're right. So because of warming, I love that you said that. That means that we're expecting 2014 values to be hotter or higher or larger than 2014 values. And the way this is set up, row 1 is sample 1 and row 2 is sample 2, and we're going to do 1 minus 2. In other words, 22.1 minus 22.9 would be 0.8. So we're expecting all of these values to be larger than 0, and then the mean of all those values to be larger than 0. Good. Does everyone feel good about that?
Yes.
Good. Now, let StatCrunch do everything else. Okay. So what I'm saying is do the rest of the test. I'm going to select all this and delete it out and do your 2000 and 2014. This is one of the ones that maybe doing it in your head might not be as simple. It's okay if it is for you, great, do that. But let StatCrunch do all this and do the test from start to finish, and let's see where we end up. So let me give you 5 minutes to see. I'll check in 5 minutes. We'll see if you've got to step 3 by then. How's that sound? Set a timer for 5 minutes. Oh, good job, sir. Okay, yo, did you get to step 3?
I wrote down step 3, the word step 3.
I got to
Nice.
step 3, but I don't know. My data just doesn't really make that much sense, I guess. Like it, I don't know. Well, I like when I always go over and look at the plot because it's just like easier to see. And it
Well-
says the T. Well, I don't know. Okay, so I got negative 2.498 for
Mm.
T. And then for P, I got 0.9872. Is that right?
So we did mess up
Okay.
because this area seems like it's way too much. So let's go
Yeah.
back and think about what I did wrong. So what we did,
I wanted to say something right at the beginning, but I didn't.
That's what I got too, so.
so it's good. It's better we made the mistake, I think.
I let it go because I said, yes, let's make it.
Yes, that's good. That was wise. So what we did was we did 2000 minus 2014. Now, which numbers are we expecting to be larger?
2014.
So this is the big number. And this
So we
is the
want
small
that to
number.
be var 1.
Well, so when we do small minus big, what do we expect to happen?
Get a negative.
A negative number. So this should have been less than because we expected, and by the way, Kayla, I think, were you the one that said that? Yeah, Kayla, you were right that warming makes us think that 2014 is going to be the big number. So that's how we chose this, but because we made 2001 and 2014 2, we need this to be a less than,
Okay.
because of the second number is the larger number based on our claim.
So Eric, this is where we kind of, when we were deciding what the alternative was, is to kind of like subtract the differences. If your differences are positive mainly, they were like, okay, does that mean like more than half? Like they wanted me to give them an exact percentage and I'm like, okay, so probably more than half. Then you could say probably a right tail. Majority, I said majority, so that's more than 50%.
So the T-stat doesn't change.
Right.
Okay.
Well, notice in your output, the mean is negative 3.4, whether we do right tail or left tail. So the fact that the mean is negative is really the one that is the dead giveaway. Which then when I set it to less than and we go look at the picture, you see it's the other side. And notice all that changed is our p-value.
Yeah.
It's 1 minus, well, the t-stat also changed. It changed to negative. So Reagan, it's really good that you noted something was wrong.
It just like I was looking at it, I was like, gosh, that just can't be right.
Yep, that means you're thinking through like, oh, definitely our hypothesis has got to be wrong, because you're not going to have that much right tail area or left tail had we done it wrong the other way.
Can you tell me again? I thought I did exactly what you told me on StatCrunch, and I am on a paired T confidence interval, and you're on a paired T hypothesis test. So
what are we doing? What are you being asked to do? What is this?
it's a hypothesis test.
Which back up here we had been asked to do a confidence interval. So they're both in the same spot. You just have to pay attention to which one are you being asked to work with.
So when I go into StatCrunch, I go stat. Do I go T-stat?
Mm-hmm. Stat, T-stat, paired.
Paired. And then I get the two columns. I get high temp 2000 and I get high temp 214. I check the differences. I leave the confidence interval at 95.
Well, so if you're doing a hypothesis test, that doesn't matter.
That's where I screwed up.
So either you're working with
Nope.
that or you're not.
That's what
working.
I did. Got it. Thank you. Thank you. Got it. Got it. Got it. Perfect. Oh, but it's 0, but it's greater than, it's not not equal. Okay, I
It
just want to do
should
this.
be less
I'll
than.
use that.
We noted
I
that.
thought warmer was greater than.
Well, that's what we were just talking about. How we
Oh.
had messed up. That's what that whole discussion was, like when we looked at the graph and the fact that we noted 2014 is supposed to be bigger. And if we do a small number minus a big number, it's gonna be negative. So this difference should be less than 0. And that
Okay.
was my fault that I messed that
Just
up.
so you know, I'm 56 years old, so I'm usually 3 or 4 minutes behind you.
No worries, no worries. Hey, stop being an ageist though. Come on
I
now.
know. I know, and I tell people that all the time. So thank you for calling me on it. Okay, so let me look at your thing.
Okay, so here's our
Okay,
output.
It's
Yes.
still different. It's still different. I mean,
Do you have
mildly
negative?
different.
Do you have
No, I
negative?
have negative 3.2533,
That
33333.
means you have an error in your data somewhere. So you copied it wrong somewhere, unless it's me. Does anyone else have negative 3.14?
I didn't I didn't even do anything but StatCrunch. I'm using the same data that StatCrunch pulled up.
Well, so you're telling
And
me
I
you
entered
didn't
it
type?
wrong. It's an operator error.
That's right. That's what I'm saying. Unless I entered it wrong.
Well, I don't know.
Possible.
I suppose we can go back and double check.
Does anyone else have the same answer as me? That's one quick way to check.
Peg, what did you have for the mean?
I've got negative 3.14 or negative 3.4.
I have. Hang on, I have to go back now because I have to
I have
retrieve.
negative 3.253.
Okay. Peg,
That's what
sounds
I
like you're
have.
right. Good.
That's what I
Sounds
have.
like I'm wrong.
Negative 3.253.
Give me a second. I'll find my mistake.
And then do you have 15 for N? And your standard error is 1.302?
Yeah.
Okay. Then I did it right. See?
Nice. Here
Second
it is. It's
guessing
right
it,
here.
though.
24.2. There's one.
Every time I second guess myself, the
the
first
one that
answer
got
was
that.
right.
Yeah, feels good, doesn't it? Here we go. Okay. Now I've got the same thing as you all. I believe. So you've got some typing to do. Which one was it? 24.2. Here we go. So you've got some writing to do, right? You got to put in your differences here that's just copy and paste from here. You're also copying and pasting your degrees of freedom, your D bar, your standard error, and you're doing a calculation there, 15, right? And then all we need down here is your T naught. And your P value. I guess we should also note that this above situation is an example of dependent sampling of a quantitative variable. That's always going to match a table like this, where you have a subtraction going on. So you have the last 3 steps to do, which I think I'm hopeful those are the steps that you all are very familiar with. Draw the graph, compare your p-value to your alpha, and write your conclusion. And like Reagan's pointing out, you can have StatCrunch draw the graph for you if you want.
I noticed that Will in the night class, Eric, he copies pastes the graph from into his worksheets. I'm like,
Yeah.
hey, buddy, that's smart.
I know, I love it. Will it work? He must have the Word version. I don't know if it'll go in here.
I think he uses the Word version.
Yeah, I've tried. It doesn't work during the version I have, but man, that would make it so much easier.
Yeah, drawing is not as fun. What
At
do y'all
least
think?
Eric and I like don't draw very good, so your guys's looks good.
Yeah, right. I probably should not be writing this all down. What's our conclusion? Reject HO or do not reject HO?
Reject HO.
This is a true statement. Oops. Good. True statement, reject HO. So I didn't even read the context. Shame on me. Oh yeah, we did. This is, so there is evidence to support the claim that the atmospheric temperature of the Earth is warming. It looks like based on these averages, the average increase between from 2000 to 2014 is a 3-degree increase.
So you guys, chapter 11, writing the alternative hypothesis is really tricky because you can't necessarily use the word like warming. In the 11.2 worksheet 2, we had the word improved, and we all thought that that should be a right tail, but it actually was not a right tail, it was a left tail, and that's so tricky.
Yes.
So if you think about it as getting better, then, you know, whatever the word is, if it equals like getting better, then you're sitting on the small end of it and you need to get better, right? Improve, so it's going to be a less than, and improve is the great is on the bigger side.
Yes, and that's, so you see, it's like you listened to me, Peg, because that's
I
kind of
know.
how I explained it.
Love it. Nice.
I only had to put it in my own words. I didn't mean to,
No,
whatever.
you took off there.
Okay, so we've got 23 minutes left. There's enough, you know, I guess I didn't write in this part, but we've got one last section to do, and that's, we're going to repeat this same kind of stuff, but it's with independent samples. So how that looks is like this. You have 2 tables of values and they're separate from each other and there's no subtraction going on. So it's, in that sense, it's pretty obvious that there's a difference between how these tables are given to you, sample 1, sample 2, versus the tables we just did, where sample 1 and 2 are smashed together and then there's a D line, a difference line. So that's like a kind of contextual clue as to whether your sampling is dependent or independent. But remember, the little phrase we're working with is one group measured twice. So it's this whether they're recording the temperature on the same day in 2 different years, just a different time frame. So maybe we could take some time, spend the last 20 minutes of class, you could work on the projects. Or maybe you'll have some other questions you want to look at. I think we've done all the worksheets for 11.2. The other thing that you should start, I was talking about this with Laura this morning, is the sample final exam. And her question was like, what's your best advice to prepare for the final exam? And it's the same, I think, as for the midterm. You need to do this before you see the answers to this. Because once you've seen the answers, it's no longer helpful study. It's just answers. We've been doing the answers, like we just did the answers to all the questions, right? So try to find some time to start taking a look at this. On page 745 is where it starts. If you don't have time yet, that's okay. Like if you're still doing 11.3 in the projects, do those first. And then probably by Thursday, you should be ready to do this, start working on this. And then come Monday of next week, hopefully you'll have it totally done. That should be your goal. Like Sunday night, if you can manage your time, if you can find it. Like, I don't know where your lives are at, but if you can, ideally, you would have the entire sample final exam worked through. And then you could say, I got stuck on number 1. I couldn't figure out the class width. And I'd be like, oh, it's the sum of consecutive lower limits divided by 2 or whatever. So that's the first thing. But I think before you do this, you should have your reference sheet put together, or your reference sheets. So I would find the set of sheets you used for the sample midterm, for the actual midterm. And you should pause and think about how useful were they when you took the midterm. And then you get to write 3 more pages or whatever we decide for the final exam, plus you have all of these. And I think we've been telling you that there's less stuff you need to write. Most of the reference material you need for the final exam are on these pages. And I think we've also been telling you, hey, write some stuff in here about like X is number of observations, right?
Successes.
And N is number of observations.
You were just testing us.
Just testing, right? So there's some of that. So maybe before you get going on this, you should have the reference material you're going to use put together, and then you should practice it. Like, set yourself down with a 3-hour time limit. I mean, this is asking a lot, I realize, but this is the ideal study method. Have your space cleared, have your StatCrunch and your calculator and your reference material, and just take this like an exam. This is a longer exam than what the final exam will actually be, right? This is 29 questions long. It's how many pages long? It's 15 pages long. So it is much longer by about 4 pages, maybe 5 pages than what you're actually going to face. But it's a really good kind of overview of what you can face. If you want to attempt every possible problem and then ones that also might not be on there, you could go to the appendices after working through this. You could go to Appendix E and work through these problems. And these have an answer key at the end.
I knew she was going to be my sister.
Oh, I love that idea. Oh, I love that idea.
So you could also, I don't know which one you should do first, but like this is the one that there's answers you get to check, and then the one at the bottom is the ones that I'm going to grade you on, and Cindy and I are going to like go over it with you too. Reagan, did you have questions? I know you were unmuted, but
No,
unmuted.
no, I'm good.
The only
right,
thing I was
questions?
it wasn't a question, it was a comment on how you said to go through your note pack. I don't know about everybody else, but the one thing that I did after, of course, having a complete meltdown several times, after I was done, I realized I had way too much material, and I'm flipping through pages and I can't find what I need and I'm getting stressed. So I loved that idea of condensing to look through what you had for the midterm, because there's pages I never even looked at.
Yeah.
That I never would have needed. So.
I agree.
super
I
good
think,
advice, Eric. Thank you.
yeah, you're welcome. Less is definitely better. I personally think.
I
Um,
overwhelmed myself.
It's easy to do. And honestly, that's why we don't say it's open book. Because personally, like, what difference does it make if it's open book versus reference sheets, right? Like,
Makes no difference. Zero
but
difference.
other than like, can you imagine having 6,000 pages that you're like,
my
oh,
God.
where was that?
Oh my God. Oh my God.
Okay, so that's that advice. We do have 15 minutes. If you'd like, you could start on the project, take a look and ask questions if you're getting stuck. Otherwise, if you're happy, you could take off and do what you need to do. This is the one time we're actually done early. It's crazy. Cindy, I don't know if you have anything you want to
And
suggest
you have
or
to go
add.
take my mother-in-law to an appointment, so
Well,
I am
do
gonna
that.
go ahead and take off. Okay, I'll see you tonight, Eric.
Sounds good. Sounds great, Peg.